Okay, this is section 4.2, some ways to prove triangles congruent, objective 2. This is very proof heavy, important section. So we're going to spend 2 days on this section, okay? All right, so I want you to try this at home. Use a ruler and protractor to complete the task below. You are using ruler and protractor to make these 4 triangles and predict whether your triangle will be congruent. You bring this sheet of paper and then we compare them with your friends, okay? And he says here, try for a reasonably accurate drawing, and you may find helpful to cut a thin strip of paper for each side, then form the triangle. So you can cut a strip of paper 4 centimeter long, and then 6 centimeter long, and then use a protractor to make that angle, and then use those strips to or use the 2 rulers. That may help as well. Okay, so in case it wasn't clear, this is homework. Okay, all right, so we are here, and objective 2 is prove 2 triangles congruent by using the same side, 3. Oh, sorry, you couldn't see. Prove 2 triangles congruent by using the side postulate and side angle side postulate. Okay, now side angle side. Oh, okay, it's not postulate. Sorry. It's side angle side, and angle side angle postulate. Okay, so we are learning these 3 postulates. These are all postulates. Okay, and S stands for sides, A stands for angles. All right, side postulate. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. If you know the 3 sides are congruent, you can only make the same triangles. And I have a stick that we're gonna try in the class to demonstrate this fact. So you know that by experience rather than just by understanding the postulate. And again, this is a postulate because you can't prove it. Okay, so in the diagram, you can have these tick marks to identify these are congruent, or you may get the same length. If it's the same length, then the sides are congruent. Okay, all right, so sometimes it is helpful to describe the parts of a triangle in terms of their relative positions. The side AB is opposite angle C, and AB is included between this side is included between angle A and B. Okay, so these are the words that we use to describe some of the postulates. Angle A is the opposite of segment BC. Angle A is included between the segment AB and segment AC. You see that? It's between these segments, right? And this side is between these 2 angles. And then that becomes important when we do this, okay? So next one, side angle side postulate. If 2 sides and the included angle, so like this is the included angle between the segment AB and segment AC, of one triangle are congruent to the 2 sides and the included angle of another triangle, then the triangles are congruent. Here's what it means. If the 2 sides are congruent and the angles between those 2 sides, the included angles are congruent, then these triangles are congruent. Here's another way. Here it's 9 and 9, 3 and 3, and angle between those 2 sides are congruent, then these triangles are congruent. So that's side angle side. The 2 sides and the angle in between, side angle side. This one is side. And here's the third one. Angle side angle postulate. Now this has a name, so you can use this in the proofs, okay? You call it angle side, angle postulate, or SAS postulate, and so forth. This one is two angles and the segment included between those two angles. So angle, side, angle. Okay, here's again. Here's the angle, 55, side in between, and angle. Angle, side, angle. Okay, so practice using side, 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 angle, side, and angle, side, angle postulate. Can the two triangles be proved congruent? If so, what postulate can be used? I want you to stop the video here and try this first. Okay, and then come back and we do it one by one. Okay, all right, welcome back. So this one, these two are congruent, and these two are congruent, and then the side is in between. So this one is angle, side, angle, postulate. These are congruent. Okay, this one, these sides are congruent, and these sides are congruent, and this side is shared, right? So the three sides are congruent. So this is side, 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 postulate. So look at this one. These two sides are congruent, these two sides are congruent, and these angles are congruent by the vertical angle. That's side, angle, side. So this is side, angle, side, postulate. So far so good, I hope. All right, this one. This is a side, two sides are congruent, right? But the angle that is congruent is not between the two sides that are congruent. So this one doesn't work because this is angle side side or side side angle, which is not one of these, right? Angle have to be here to be congruent. So this is none, not congruent. Okay, this is where it got tricky, I think, right? Here is, here's again, this is side, angle, side for this one. And this one is side, side, angle, right? This angle that is congruent is not between the two sides. So these are not congruent. And this one, this side is congruent, and these sides are congruent. And again, this side is between the sides that are congruent, but this one is not. If this was here, then they are congruent, but since it's not, this is not congruent. Let's try a proof on proving triangles congruent. This is what you'll be doing a lot in this section. Okay, so supply the missing statements and reasons in the following proof. E is the midpoint of MJ. E is midpoint of MJ, so you can do this. These are the same lengths. And TE is perpendicular to MJ, so this is 90 degree and this is 90 degree. Now, if you look at this side is shared, so these are congruent, right? So you already see this is side, angle, side, side, angle, side, and these are congruent. So that's what you have to prove here. So E is the midpoint of MJ given. So the two segments are congruent. Definition of midpoint. If a point is a midpoint, then it creates two congruent segments. Or the segments created by the point are congruent or something like that, right? So you can write here, right? You know what you're writing. TE is perpendicular to MJ, that's given. So that means the MET is congruent to JET. MET is congruent to JET. And that one, so the two perpendicular lines create two adjacent and congruent angles. This was one of the definitions that we learned when we did the perpendicular lines. We can go straight there. If you didn't remember this, you can make this 90 degree and this make a 90 degree and set them equal by substitution. But this, you can go straight here with one reason if you remember it. Okay, and TE is congruent to TE. And you know the reason here, right? So you just fill this out as a homework. And triangle MET is congruent to triangle JET, and this is side, angle, side. So this is what you write: side, angle, side, posture. Okay, these are the things you'll be doing a lot. All right, explain how you would prove the following. All right, so I'm going to do the roadmap test for you. And then you try to write it out, the statement and reasons for homework. Both. Not just reasons this time, okay? So HY is congruent to LY, so these are congruent, right? And WH is parallel to LF, so these are parallel, okay? So that means that these are parallel, and if you look at this as a transversal, these are congruent by, you know that, right? Okay. And then these are also congruent by the same reason. Hopefully you know. So then this is hold on. So this is angle side. Oh no, I'm sorry. The congruent one is HY and LY. So these are congruent. Oh, here it is. The vertical angles. Vertical angles are congruent. All right. So see, I was confused because angle side doesn't work. You need this side in between. But here, these angles are also congruent. So you got an angle, side, angle here. Angle, side, angle. So you write it out. I showed you why these are congruent, right? So you don't need this. You don't need these. You just prove that these angles are congruent, these angles are congruent, and these are given. And therefore, it's angle, side, angle. You write it out, okay? Okay, and here is this one, can side angle guarantee triangle congruent? I will show this to you in the class, okay? Why side angle doesn't work. Like this one, where was it? The side angle, this one. See, this is side angle, side angle. This one doesn't guarantee the triangle is congruent. And I will show that to you, and the rest is exercise, and there are a lot of proofs here. See, proof, and more proof, and then the problem. So we're gonna spend 2 days on this, okay? But we are done for today. Make sure you do the survey.